Hey, this is Bill DeWeese with Long Strange Journey, and not on the water because we're here in the driveway, and this is another how-to. And embedded in this how-to is also a why-to because I'm doing something a little strange, as always. And I am installing the Lowrance or Simrad Navico Point-1 GPS antenna. I'm installing it into the network on my boat. And I'll show you what this is particularly useful for my boat. Being a small craft inshore vessel that does a little bit of near shore, I usually keep my boat within 30 miles of shore because you never know what the sea conditions are like, and it can get kind of rough. So, but I do like to do nearshore fishing, and there's a couple of reasons why this is actually a really important gadget, and it may not be very obvious to you exactly why you would want to have it. So, the Point-1 antenna is a puck. That puck is typically flush mounted somewhere on your boat. I do not like drilling holes in my boat, and being a skiff, I don't have a lot of real estate on my boat. I don't want to drill any unnecessary holes. I don't want to have wires. So I'm going to put this GPS and heading sensor into a hidden location. And for that, I'm going to show you something truly strange. So I went to Amazon and got some shelving material. Now, this shelving material is 100% Lexan. So it's an 1/8-inch shelf, goes onto your room. You put your little rubber dinosaur that you 3D printed, or you put your cell phone watch charger, and you keep it next to your bed. It's a cute little shelf, but most importantly, it's a right angle. It's made of virtually indestructible and non-corrosive Lexan. So combined with stainless steel, this allows me to have some screw-mounted system, which I have back here in the back corner of my boat. So here in my equipment locker, I have mounted one of those onto the thigh panel on the port side of my boat. That's not the outer hull. Be careful, don't do any drilling on your boat until you know what you're drilling. But as you can see, there was a piece of equipment there before. There's actually a rust stain from some dumb piece of equipment that was there before. But I've reused that mount. The most important thing you need to understand here is, why do you want to do this? What do you get with this GPS puck antenna? And let me explain. Point-1 antenna goes onto a NMEA network, just the same way your Lowrance is on the NMEA network, just the same way my Suzuki is on an NMEA network, and any other number of things you can have on your network. So the Point-1 antenna is part of a NMEA network, and it provides a series of data points specified in the NMEA specification. They have these numbers for their PGNs. The first grouping that you see above the dash line relate to the GPS cone antenna and what it's able to provide you from the Lowrance puck antenna. Most of these are redundant to what you're getting on your multifunction display, your chart plotter, right? In a boat as small as mine, I don't need a second GPS antenna. So all these first 6 items, system time, positioning with a rapid update, course over ground, speed over ground with rapid update, GNSS data, DOPs, and the number of space vehicle satellites in view, I don't need any of that. So even though I can get that in a concealed location, I don't actually need to have it. So I select the Lowrance console unit, and all of my units, the bow unit, the console unit, they get their data for GPS location and the boat's location on the earth from the primary Lowrance system. But in addition to the GPS capabilities of the Point-1 GPS antenna, you also have the magnetic heading sensor. This is what I need. This is what I will take advantage of. So normally for an inshore boat, you might not even care about this. For the most part, I can be going around and fishing in certain areas, and I can see line of sight, right? So I could see there's an island here. I'm just looking at Chazawiska area. But there's an island here, and I can see that island in front of me. So I always know my heading by virtue of what I can see. But if you go offshore, near shore, and you lose sight of land, you need to be able to have your heading so that you can know where an object might be. So what your unit is doing as you're moving around is your unit is interpolating your heading from progressive position. So it knows what your position was, say, a second ago. It knows what your position was 2 seconds ago. It knows what your position was 3 seconds ago. And it knows what your position is now. So it can interpolate your heading from that, and you typically get a heading straight off the Lowrance. That works great if you're moving. But if you stop moving, you put yourself on spot lock, or you throw out your anchor on top of a piece of structure, you will end up with a map spin because you're no longer moving and it does not know your heading. So the only way for it to know your heading would be through a magnetic heading sensor because you're no longer projecting forward movement. So if you take one of these common artificial reefs, right, and you're going to be going out and you're going to be, say, grouper fishing, there's a bunch of different locations here. This is Ben Dixon Reef. There's a bunch of locations here at Ben Dixon Reef. You won't know where they are in relation to your current position for very nearby objects. If you scan a piece of structure and sit on top of it, you're fine. But nearby structure, if you're throwing some kind of a lipped diver after a grouper, you won't know what direction to throw it in. So what you want to do is you want to invoke the heading sensor and make it your indicator of your actual boat's vessel heading, even when it's not moving, because it's magnetic. It doesn't matter that you are not moving. So that's why I can conceal this, and I have concealed it using this little right angle shelf. It's mounted inside of the boat. It's running completely parallel to the keel of the boat, and it's permanently mounted flat on a right angle to the boat itself. So it's the same as if you had mounted it up here on deck, or if it's the same as if I had occupied this space here and mounted it on the top, although I don't have any interference, and I also can continue to use this surface for other temporary things. The purpose of the shelf is to provide me that exact ability to have this mounted in a concealed location. So let's start by talking a little bit about the NMEA network itself. So in order to integrate the Lowrance Point-1 antenna, I needed a NMEA network. So I added the NMEA network to add this, and also add the units that I have on here for the display units, and also to add the Suzuki motor with the digital interface so that I could monitor my Suzuki from my Lowrance for maintenance and other purposes. So what you start with typically, it's best to think of a NMEA network as a snake that runs around your boat. And that snake has a head and that snake has a tail. The head and the tail are both terminated. So inside of here for the actual one that's being used is I have a terminator on the leftmost first tee. Typically the first drop from your NMEA is a NMEA power cord. This you typically get with a starter kit, but you can buy all these things separately if you want to. But a number of companies, Lowrance, Garmin, Encore, they all have starter kits. The starter kit usually is coming with a couple of T's and then the power. And then you create yourself a suitable backbone. So in reality, in my boat, underneath here, I have a terminator going to the first tee. That tee goes to a power drop, just similar to this one. Then it goes to a second tee. The second tee has a drop which runs right up in my bundle to the first Lowrance. Then coming to the outside egress of that tee, I have a backbone. That backbone runs down through my conduit, out the back to another pair of tees. So that would be effectively these two tees right here. So the backbone from the console comes into here, and I have a T that runs down to pick up the SMDI interface for the Suzuki. And then I have a T that picks up the new 0.1 antenna at the install point. Then it goes finally to a terminator. I don't really use my forward Lowrance. I have a 9-inch Lowrance on the bow. I don't really typically have that on the network. So what I end up with, and I have to trust this finally, but what I end up with is a completely concealed location, no wires, nothing that I need to worry about, and I have my heading sensor. So when you go to your network now, when you go to your network and so the NMEA 2000 network, you can look at your data sources and you'll see that you have GPS can be my HDS live. It could be my 0.1. If you can auto, which would default to the 0.1. I don't want my GPS coming from my 0.1 because I've got it hidden and I don't want to have any obstruction problems, but I don't care about the GPS signal and its data points coming from the cone antenna of the 0.1. It can just as easily come from this primary unit. And so my simplified configuration, I derive my GPS location from my Lowrance. It works beautifully. But my heading now comes from the 0.1 on the network. My rate of turn, my attitude, my pitch, all comes from my 0.1. So I have now access to that data through the 0.1 system. So if I look at my data sources, device list, sorry. So if I go to my device list and I go to my 0.1, you can see that I've got my 0.1 antenna and I can look at my data. This is all of the data that comes from my 0.1 system. And even though that's hidden inside of my my equipment locker, I have 12 satellites in view. So there's 12 space vehicles that I can derive my position from. So even though I've hid it, I've not made it so that it is impossible to use. But the focus here is not to get GPS. I've got a good GPS in my Lowrance. But you have the satellites in view and you have the ability to use that GPS. But more importantly, I've got my system set up so that I can get my compass heading all from the magnetic heading sensor and not have to worry about the chart spinning when I'm stationary, which is typically what would happen. So one other point that I would point here is that under the data and configuration, you can set your compass configuration. You can set all the information that you need to under advanced options. I asked ChatGPT, if you lived in the Tampa Bay area, what would be your declination or your magnetic variance? And it would be about 6 degrees or -6 degrees. We're pretty close relatively to the equator compared to other parts of the United States. So we don't have a radical declination, but you can adjust your declination and it shows my magnetic variation of being -6.1. Before you go through the whole process here, after you install that unit, when you go through your network and you go through your devices and you go to the 0.1, you can go through a calibration sequence. And if you start the calibration sequence, you gotta start moving your vessel in a 390-degree circle at a rough rate of turn of 2 to 3 degrees. And that will go through a whole process of calibration. All right, so as you can see, we're properly configured. This little road here, the satellite imagery doesn't cover land, right? So it's pixelated, which is fine. This road here is heading due north. And so I'm sitting in my driveway and I'm facing between my neighbor's 2 houses, and that's exactly where my 0.1 heading is indicated, which is based upon the magnetic heading sensor. And that's exactly, you'll see the red line, which is the interpreted heading from the Lowrance unit, which is struggling because we're not moving. So it doesn't know where I am versus where I've been because I'm not moving. So it's fluctuating. And so what you would get in a situation like that without a heading sensor is that map could spin and it will be really off because it doesn't know where north is. It doesn't know your attitude. It doesn't know your heading of your vessel. But now you got the 0.1 antenna and it's parallel to the keel of the boat, so it knows exactly where due north is. So the 0.1 antenna can give all the information that you need from this system. So now you've got your NMEA network in place, your Lowrance unit, you've got your heading sensor, and again, you can have other things. You can have fuel flow sensors. There's 1,000 different things you can get for your NMEA network. Okay, so we covered the Y2 part of the video, and that is that we want to have our cake and eat it too. We want the heading sensor, but we do not want the holes. We do not want the visible puck. We do not need the GPS, but we have it should we want to use it and we have visible satellites. Secondly, the how-to. We use a reliable Lexan product that's not going to corrode. It's not metal. And we've got it perpendicular to the wall of the boat so that it's parallel to the keel with the little arrow that's on the front of the 0.1 antenna to indicate the center line parallel to keel. And then we put that in there and we mount that, and then we do the calibration. So once we've got the calibration, everything is set and we get a good solid line even though we're not moving, and we can ignore the line or remove the line from the interpolated attitude of the boat or the vessel heading of the boat. And so that's the end of that, and we're set to go. So now we're ready for wintertime, offshore, nearshore fishing. When the fish move in closer, I go out to the 20s and the 30s foot depth, which for Nature Coast is about 20 to 30 miles, and do a little bit more nearshore fishing than I would normally do. And I will take much more advantage of the lockdown heading from the magnetic heading sensor when doing that. So I hope this inspires you or helps you. If you have any questions or thoughts or comments, feel free to leave a comment in the video. Thank you for watching. Be sure to like and subscribe.